All right, this is chapter 8, and in chapter 8 we're going to move from graphing one variable to equations with two variables. If we have an equation like this and we solve for it, we subtract 5, we get x equals 5. So if we have to graph this, we would graph it on a number line, and those would be the solutions. Now, you'll notice that when we have two variables in equations, we have to not only graph, we have to graph in two directions. You have the x-axis and the y-axis, and we call that a coordinate plane. So a coordinate plane, as we know, looks like this. And so our solutions will have coordinates. It'll have an x variable and a y variable. We move positive on the x-axis, we move negative on the x-axis, we move positive on the y-axis, and we move negative on the y-axis. So when I get a point like 3, 5, I go 3 on the x, 1, 2, 3, and then I go 5 on the y, 1, 2, 3, 4, 5. So it has two dimensions, and that's the basic tenets of graphing on a coordinate plane. So what we're going to deal with first is not the graphing, but just finding solutions for these equations. So we get this equation 5x plus 2y equals 23. And they want to know whether this coordinate is a solution. This would be the x. This would be the x value, so you're going to plug it in for x. This is going to be the y value, so you plug it in for y. And then we'll simplify. So 5 times 3 plus 2 times 4 equals 23. 15 plus 8 equals 23. Does 23 equal 23? So yes, this coordinate 3, 4 is a solution. When doing these equations, I don't want you to stop here. Don't assume that I know that you know that 15 plus 8 equals 23. You must take it down and completely simplify it. Let's look at the other point. We've got 7, negative 6. So my equation is 5x plus 4y, 2y equals 23. And my x value is 7. My y value is negative 6 equals 23. That's going to give me 35 minus 12 equals 23. 35 minus 12 is 23 equals 23. So the coordinate 7, negative 6 is also a solution. Let's try a couple of these other ones. 4 times 6 minus 5 times 7 equals 9. Hey, Mr. Mack, how did you know that 6 goes in for m and 7 goes in for n? Aren't coordinates x, y? Absolutely. But if you have other variables like mn or ab, they're always going to be alphabetical. M comes before n. So we always place those variables in alphabetical order when we're given in our coordinate. So we get 24 minus 35. 24 minus 35 is negative 11, and it does not. So the coordinate 6, 7 is not a solution. And remember when we were graphing this solution, right? We were graphing this solution or we were taking this solution and putting it on the graph. If I tested this point over here and plugged it in, let's make this -3. So if I plug -3 in there, it wouldn't have a dot. If I test that, -3 plus 5 is 2. 2 does not equal 10. So notice it's not graphed. None of these are graphed here. So that means that none of those are solutions. The only solutions are the ones that have been shaded in or graphed. When we get on a coordinate plane, you'll notice that it'll be a line, something like that. We'll grab a couple points and then we'll connect them and we'll create a nice graph. So any point on this line is considered a solution to that equation, meaning if we plug that coordinate in, it'll come out true. If we plug in a point not on that line, it's going to be false. These are false. All the green ones are true. True, true, and every point in between those points or every point on the line are considered true values. Anything not on the line would be false. So we could assume that if we solve this equation, this line, in fact, let's, not photos, excuse me. Photos, hello. Let's do Desmos, D-E-S-Mos, and let's take this equation. And that equation is 5x 2y. 5x plus 2y equals 23. So if we look at it, that's the equation. That is all of the solutions. That is the graph of every solution to this equation. So our coordinate was 3, 4. If we pull in and go to 3, 4, 3 on the x, 4 on the y, we notice that it lies on the equation. So if we take this equation, 4m minus 5, 4m minus 5n equals 9, I think it was. I don't know what happened there. Let's change. I guess it doesn't like non-variables. Let's use x and y. If we look at that point 6, 7, if we go over to 6, 7, so here's 6, here's 7. Notice it doesn't lie on this line. So let's look at the next point that they want, 6, 3. Let's see if 6, 3, 6, 3. If we touch it, watch, if we go right on it, there we go, 6, 3 is a solution. So we know that when we plug this in now, we're going to get a true statement. 9 equals 9. So let's try it. So 6 and 3, 4 times 6 minus 5 times 3 equals 9. 24 minus 15 equals 9. 9 equals 9. So the point 6, 3 is a solution. And you get the same understanding for problem number 3. Solve each equation if x and y are whole numbers. So now they want a solution to this. So before they gave me a point and I had to test it, now I have an equation and I don't have any point. So where am I going to start? Well, we use what is called an H-chart. And it looks like this, and it's a way to get as many solutions as you want. You're going to plug in a point. 1's an easy, but 0 is the easiest. So we're going to plug 0 in for x and then solve for y. 2 times 0 is 0. 0 plus y is y. So when x is 0, y is 6. So my coordinate, or my solution to this equation, one solution, is 0, 6. That lies on that line. It is a point that consists of all the solutions. And how many points are on there? An infinite number. So we can continue to plug in if we want another point. 1's a great number. -1's the next easiest. So we go through, and whenever we graph equations, we like 3 points. We like 3 coordinates in order to have a good basis, a good form of a general shape of the line, shall we say. So I'm going to plug in 0. 5 times 0 plus y equals 7. 0 plus y equals 7. Y equals 7. So my coordinate is 0, 7. Notice we're using parentheses. All coordinates have parentheses around their units. I think I just did that one. Let's delete that page. Let's delete that. No, all right, you're going to be... I like this one. This one is a very unusual. I don't think I've ever seen this type of problem before. Hence why we're doing it as an example. So I'm going to plug in a point. Let's not plug in 0. Let's plug in 1 this time. Okay? So if we plug in 1, we get 1y plus 1 equals 9. So we have y plus 1 equals 9. We're going to subtract 1 from both sides, and we get y equals 8. So y equals 8 when x equals 1. Let's plug in another number. Let's plug in 2. So you have 2 times y plus 2 equals 9. Subtract 2, we get 2y equals 7. Divide by 2, y equals 7 halves. So my coordinate is going to be, my new coordinate, my next coordinate is 2, 7 halves. And we can keep plugging in numbers, and we can continue to do that. I think that's it, right? There's a section in 8.1 on the worksheet where you had a problem where it said solve each equation for y in terms of x. So all we're doing here is we're isolating for the variable y. We're not looking for solutions here. We just want to set this equation, and we'll look at this first equation, number 18. We're looking at this equation. We want to get it to say y equals. We're going to find out that later on in section 8.2, 8.3, that if it's in a format where it's solved for a variable, it actually makes it easier. So how can we get y by itself? There's two things that are happening to it right at the moment. 2x is being added to it, and -1 is being multiplied by it. So what do we get rid of first? We always get rid of things being added and subtracted. What's going to get rid of a positive 2x? Well, a negative 2x. This negative sign is not attached to the 2x. This negative is attached to the y. So many students will add 2x, and that's bad because a positive 2x does not get rid of a positive 2x. Only a negative 2x. So these will cancel. I'm left with negative y equals negative 2x plus 5. Do not put that 2x to the right of it. Too many students write this. And we know better at this stage of the year that variables come first. Now, we haven't gotten y by itself. There's a -1 in front of it. And there's a couple ways that we can get rid of a negative, but I'm going to show through multiplication. And we have to distribute it to both terms. So that gives me this. -1 times -2x is positive 2x. -1 times positive 5 is -5. So that would be my answer. Notice it says y equals. So we've solved for y in terms of x, meaning our answer has the variable x in it. That's in terms of x. I said there was another way to do this, and we can do it. What's happening to y? It's being multiplied by -1. How do we get rid of things multiplying? We divide by -1. But what you have to be aware of is that you have to do it by each of the terms on the right side. So here we have -2x over -1. Two negatives make a positive. We have positive 5 divided by -1. A positive divided by a negative is a negative. So both ways we're able to isolate for the variable y. So that would be my answer. We're trying to get y by itself. We're going to get rid of the x being added to it. We're left with 3y equals negative x plus 9. We want the variable to come first. This time we'll show that we divide each one by 3. We get y equals, you can do this. It's probably not the best answer. It looks nice, but for what we're going to use it for, in this case, I'd much rather you write it like that. What's the coefficient of x? A negative 1 in the numerator. 3 is in the denominator. So that's why that's a better answer in this chapter, only in chapter 8. Otherwise, I don't mind that. Let's go back to this part right here. 3y equals negative x plus 9. What's happening to the variable is being multiplied by 3. I can multiply by the reciprocal. Any number multiplied by its reciprocal equals 1, gets us y by itself. And I would have to remember to multiply everything on the right side by 1/3. So we get negative 1/3 x. 1/3 times 9 gives me 3. Same answer. And the last one, we're going to get rid of 5x. We're going to move it, shall we say. I get 4y equals negative 5x plus 10. I'm going to divide each of the pieces by 4. That leaves me with y equals negative 5/4 x plus 5 over 2. I like that answer a whole lot better than what the book is showing you. The reason why I like that, also you have to remember to reduce that fraction. Always reduce your fractions. We could get here, and we can divide by 4, and I see the book is doing this. Yeah, that's a tough answer. That's not really going to be beneficial. That's beneficial and maybe in some of the other sections that we have, but not in Chapter 8. Chapter 8, when we are solving and graphing, it's going to be more beneficial to be able to deal with the equation in that format other than this. We cannot simplify 10 and 4 because 5 cannot be simplified by 4. So this is my answer. I'll accept it. I'm just telling you, and you'll find out in the next couple of sections how this really doesn't help us that much.